So loop optimization. So another important topic which pertains to module number 3. So you will understand the subject on example based scenario. Okay. So I have given 4 major topics here. The first is code motion, the second is induction variable elimination, the third one loop unrolling, and the fourth one is called as loop jamming. Okay. So we'll discuss about one by one with appropriate examples. So code motion and induction variable elimination, we have already learned that, but anyhow, people who have not attended, once again go through for it. So what is code motion? Say for example, I will start from the definition and then I will actually highlight the examples pertains to that. Okay. A code motion, an expression which does not change value, inside a loop can be moved outside of the loop, can be moved outside of the loop. That means if the value does not change, okay, then running the loop, okay, for that corresponding statement is inefficient. Say for example, I have a loop and I try to execute the loop for 10 times and I am again getting the same value. Then that is actually an inefficient process. Okay. In that case, instead of running that, you just move the statement outside of the loop so that it will get executed only one time. Okay. Now I will highlight what is the example for this. Take this definition. The expression which does not change the value inside the loop can be moved outside of the loop. That is called as code motion. For instance, shall I go to the next one? For instance, I have a loop here. Let us assume I have a while loop here. While I lesser than or equal to 5, I is equal to 1. And here I make C is equal to A plus B. Forget about the values of A and B now. I equal to I plus 1. Okay. Now you closely observe this. I have two statements inside the loop. Okay. Which value does not change at all? C equal to A plus B does not change, where I equal to I plus 1 keeps on changing. Okay. So now there is an impact for the second statement, but there is no impact for the first statement. Okay. So in this case, what you have to do? You move this statement outside of the loop so that it will get executed only one time, and running this number of times is inefficient procedure. Okay. So transform this code as I equal to 1 and I replace this statement outside of it. C equal to A plus B while I lesser than or equal to 5, and inside this I try to execute only one statement. That's all. This process is called as code motion. Move the statement outside of it. So I am using a while procedure here or while loop here. You can use a for loop instead of that. Okay, while or for, whatever loop it is, you try to do that. This process is called as code motion. Okay, so you highlight that with a suitable examples. Whenever you explain any concept which pertains to this topic, explain with suitable examples. Shall I go to the next one? Clear? So the next is induction variable elimination. So induction variable elimination. Induction variable elimination. So induction variable, induction means it is called as a jargon, okay? It is a jargon. Jargon in the sense, index variable is called as induction variable. That's all. Okay. What is an index variable? When you use I inside a loop, when you use J, when you use K, that is called as an induction variable. Okay. So such kind of variable has to get eliminated. Now see here, eliminating or removing an index variable. Removing the index variable and reducing the strength of operation. And reducing the strength of operation. Reducing the strength of operation is called as induction variable elimination. Now the question arises, what is meant by reducing the strength of the operation? Very important question. What is meant by reducing the strength? How will you reduce the strength? Say for example, see, simply we are actually computing, simply we are actually dividing, multiplying, everything is happening in computer systems, but it involves a cost. Okay, lot of complicated circuits are involved when you try to use compute multiplication, when you try to divide, so many complicated circuits are involved. Okay, now what is meant by reducing distance? Say for example, let us see that I have x is equal to x star 2. Okay, multiplication is a complicated operation. Okay, now that is having higher precedence. Suppose I want to replace this multiplication, but I don't want, I want to get the same answer by replacing with another operation. Okay, the reduced operation here. Say for example, multiplication can be replaced by addition here. Say for example, if I want to replace this, I can do like this: x is equal to x plus x. Am I right? I'll get the same answer. Let us assume that x is equal to 4. 4 into 2 is 8. Okay. Now, 4 plus 4 is also going to result in 8 here. Okay. Now, star is a higher precedence operator and I am replacing with that with a lower precedence operator. So, that is called as reducing distance. Are you able to understand? Okay. Suppose, if I want to do the same thing, say for example, if I want to divide it, what do you have to do? Multiplication, division can be done with the help of, replaced with the help of subtraction. You can do that. Okay. So that is also called as reducing. So when higher precedence operator is replaced by low precedence operator, then that is called as reducing in the strength. Okay. Now listen carefully. I will just give an appropriate example for this, a suitable example for this. Let us assume that I have a statement called as t equal to 1. Okay. I have a statement called as t equal to 1. Okay. Now I have a statement called as I is equal to 1. Okay. Now I have a loop here. I is called as index variable. While I lesser than or equal to 5, t equal to t star I. Okay. And I equal to I plus 1. Now what is an induction variable here? What is an index variable? I is called as an index variable because that actually helps you to function the loop. Are you able to understand? Now what is the concept here? I want to eliminate that index variable, but in no way I should affect the output. Output should be similar, but index variable should not be existing. Are you able to understand? Now see here, what is the value of I? Initially 1. I takes the value of 5. What is the value of t now initially? T will be initially 1. Finally, what is the value of t now? T will be 5. When I run it, t will be 5. Okay. I don't want this I variable at all. Are you able to understand? Okay. Now, how to replace this? So, I want to eliminate this I, remove this I should not be there. What is the value? T is equal to 1. Finally, I should get t is equal to 5. That is the output here. Okay. So, inside this loop, I write while t lesser than or equal to 5, while t less than or equal to 5, okay. Now, t equal to t plus 1. So, I actually replace this multiplication with addition. Okay, finally when I do it, what will be the value if I run this loop here? Finally t value will be 5. Are you able to understand? Okay, so that is the scenario we are using for this. So this is called as induction variable elimination, and finally you are reducing the strength of operation. Reducing the strength of operation actually reduces the burden of the processor. Clear? So that's it. The second loop optimization technique. So you know what is meant by code motion, and you know what is meant by induction variable elimination. I have given one specific example. If something strikes in your mind apart from this, you can do that. Clear? Any doubts in this? Have you taken it? Shall I go to the next one? So the third one is called as loop unrolling. Okay, what is meant by loop unrolling? So reducing the execution time of the loop is called as loop unrolling. For example, listen carefully. Loop unrolling. Reducing the execution time of a loop. Reducing the execution time of the loop. Okay. Now, how will you reduce this? For example, listen here. I make a for loop here. So, for I is equal to 1, I less than or equal to 100, I plus plus. Okay. Now, get in. Now, this loop will be executing how many times? This loop will be executing 100 times. Am I right? Okay. Now, inside this, I make a function called as fun. Okay. I call a function. Okay. This is not actually a real function. It is called as a hypothetical function. Hypothetical function means a namesake. I'm using a function. You don't actually perform anything. Okay. For explaining the concept, I'm using this fun function. Okay. Now, obviously, this call will be executed how many times? 100 times. Are able to understand? That means this loop execute 100 times. Okay. Now, what is actually loop unrolling? Reducing the execution time of the loop, but in no way I should get affect the output here. Output should not get affected. But using some optimization techniques, I have to improve the efficiency of the code. Okay, now see here. So what I have to do here is, I want to reduce it. So for example, I'm making it like this. For I is equal to 1, I less than or equal to 50. Okay, now I make I plus plus here. Inside this, what I have done, instead of writing, making a loop execute 100 times, I have reduced it to 50. Okay, but how come actually I make a change over here? This has to be executed 100 times. Am I right? Okay, so now to do that, I make a call 2 times. Function is called first time, function is called second time. Okay, for every one time execution of a loop, actually function will be called 2 times. In no way this will get the affect the output. Okay, so this concept is called as loop unrolling. Make a note of it. Explain with appropriate examples whenever the concept goes on. Clear? Let's go to the next one. The fourth concept. The fourth concept. So people who have not attended, okay, I will send you the link here. If not for CAA 2, okay, before the final examinations, everything will be available. Go through the link once. That is sufficient. Okay. So the next is loop jamming. Loop jamming. Okay. Now what is meant by loop jamming? Merging more than one loop together. Merge more than one loop together. Okay. How will you merge? How will you merge it? Blindly you cannot merge it because output should not get affected. Am I right? Okay. By merging two loops, the output is getting affected means the intention of the code is actually squandered, isn't it? Okay. So what you have to do is, say for example, I make a for loop here. For I is equal to 1, I less than or equal to 50, I plus plus. Okay. Now I make like this, A of I is equal to I. Okay. Now I make another loop here for I is equal to 1, I less than or equal to 50, I plus plus. Now I have another loop, B of I is equal to I. So now all these two loops actually run in the same code subsequently. This will be executing 50 times, this will be executing 50 times, put together 100 times. Okay. But understand that when you try to merge these two loops, identify the upper limit and the lower limit should be identical. Okay. Lower limit is 1 and upper limit is 50 for both the loops. Now, what I'm going to do here is, so instead of writing two loops here, I transform this into one loop for I is equal to 1, I less than or equal to 50, I plus plus inside the for loop. Inside the for loop, what I have to do? I have to make A of I and B of I together, isn't it? So I make A of I is equal to I, B of I is equal to I. That's all. Now instead of executing 100 times here, I try to execute only 50 times. That's it. Okay. So this concept is called as loop jamming. Are you able to understand? Clear? So learn the concept with examples. Okay. I'm not saying that you have to exactly write the same examples over there. Try to present your own examples, but without changing the concept. Clear? Any doubts? Any doubt do you have? By the way, block பண்ணீங்க